Awesome. What an awesome conference, by the way. So this is my first time being out at AppSec Cali. I was here in LA about a year ago presenting on risk management at the ISSA chapter, and this is pretty incredible. I was one of the founders of a conference in Austin, Texas called LASCON, Lone Star Application Security Conference, and it's really cool to see what the guys here in LA have put together because I think it independently mimics a lot of the things we figured out with the LASCON conference. So you guys are very lucky to have guys like Richard and Cassio and whatnot who have organized such a great event. Give them a round of applause, please. Awesome. So if you're here with me today, hopefully you want to learn about architecting security in the cloud. This talk was basically, for those who don't know, I created a free open source risk management tool called SimpleRisk. And one of the cool things that stemmed from this is I had a lot of people coming to me and asking about, tools, features, functionality that I could add, and then eventually people started asking if I could host it for them. And my background is I ran the risk or the information security program at National Instruments. And so I had some of these skills around the security side. I used to be a web systems engineer, so I had some skills around the building system side. And I thought, yeah, I can do that. And it ended up being a really cool opportunity for me because I've never been able to build something from a clean slate. I've never been able to start from scratch and then build from the ground up. And I thought, if I have this opportunity, how do I use it to make the most secure platform possible? And we all know that there's trade-offs between security and usability. And so, some of those things that I encountered along the way. But ultimately, I built a platform that I thought, this is really good. And so when I first gave this talk, this is, I think, the third time I've given this talk, it was more of a trial. It was, all right, tell me what you guys think. Am I on the right path here? And then the second iteration was like, okay, I have a little bit of validation. Tell me if you guys think I'm wrong. Now I'm feeling pretty confident, so feel free to knock me down a peg. But the goal here is to kind of share what that architecture looks like, what I built, and kind of the thought process behind building it. You guys with me? All right, good deal. So I talked a little bit about who I am. I mentioned that I run the security team at National Instruments. I mentioned the SimpleRisk stuff. I also just finished up a 4-year term on the OWASP board of directors. So I've been involved with the OWASP Foundation for over a decade. I'm one of the people who kind of helped to get Karen Staley, our new executive director, on board. And that was kind of my last, as I was running out the door, one of my goals was to make sure we had a strong ED to kind of take over the foundation from there. And if you want to reach me, you can reach me on Twitter, or I keep a blog. I don't blog very often, but when I do, it's very, very important. So feel free to check that out. So the first thing I wanted to start with was the cloud, because I think cloud means different things to different people. So if you're somebody like me, who in my customer role at National Instruments, it's SaaS, right? I'm paying for some application that runs in somebody else's data center. But then if you flip the script, as a hosting provider in my SimpleRisk role, it's somebody else's data center, and I'm just putting my application in there, and I kind of have to figure out how to build this. And my challenge here was SimpleRisk, the open source risk management tool, was originally built as something that I was using to manage risk at NI. And it never really was, at least in that iteration, intended to, hey, I'm going to give this away and other people are going to run it in their environments and whatnot. And so, it was probably 3 to 6 months after I first started working on it that I finally felt confident enough to open source it, and I ended up releasing it at the B-Sides Austin conference back in 2013. And as I mentioned earlier, the business side of SimpleRisk, the hosting it for customers and things like that, was probably even a year after that when people were asking me, hey, can you do this for me? It was like, okay, I guess I can charge you some money to host it for you. The cloud in this case was really leveraged for agility. I wasn't in the position where I was going to, buy space in a data center and rent out, or buy Dell servers and put those in there, and I'd buy storage and figure out backup solutions. For me, as a startup, it was, how do I get this stuff out there as quickly as possible, as secure as possible, and not have to spend, so much time building out the infrastructure that, I just kind of put a crappy product out there. And because the data hosted in here is risk for lots of different companies, security was a huge concern, right? So the architecture behind SimForce is pretty simple, ironically. We use Apache primarily as the web server. In most cases, we use Nginx as a front-end proxy, or you can run it on IIS. The code itself is written in PHP, and it uses a MySQL database backend. And I know this is OWASP, so I know what you guys are thinking, right? PHP, right? And so I wanted to call this out up front because you guys are like, well, PHP is the most insecure language out there, right? So a little bit old data, but still very much relevant. So White Hat did a lot of analysis on this, and they said, all right, it really doesn't matter. .NET, PHP, ASP, Java, the number of vulnerabilities that we find in each language is about the same. And they took that even a step further, and they said, at the present time, we can say that all of the aforementioned items, including language, industry, organization size, the development process, they don't matter much. And if they do, it's only slightly and under very specific conditions. So really what they're trying to tell us is that the language that you use to develop really doesn't matter. And I would argue that what does matter is how comfortable you are with a language, right? So if you take a developer, and it's kind of funny because when I first started working on SimForce, I was like, hey, why don't I try writing this in Ruby? I've always wanted to learn Ruby. Big mistake, right? Because you spend so much time trying to figure out the new language, and you're way more prone to develop vulnerabilities into a language that you're unfamiliar with than a language that you're comfortable with. So in my case, why PHP? It was because the same code works across many different platforms, right? I can use it in the Windows environment, I can use it in a Linux environment, doesn't matter. The installation is really easy, right? There's lots of documentation on installing PHP. Just, Google LAMP and you'll have a whole series of instructions out there. In cases where you do have issues and you're struggling with how I do this, there's tons of documentation out there, right? It's really easy to Google, hey, why do I get this error in PHP? And, 10,000 people respond, do this, you idiot, right? And in my case, like I said, I knew PHP better than any other language. So for me, it was really easy to kind of figure out, like, hey, why would you do this in Ruby, you jackass? Because you can do it in PHP and you're going to develop, 100 times faster doing that. So with that said, you still have to think about security, right? And this is an OWASP conference, so I absolutely have to start off by telling you guys, we have to use the coding best practices. And these are simple things, right? Validate your inputs, output your outputs or encode your outputs in terms of passwords and things like that. Hash it, use salts, only do data comparison, use industry standard crypto algorithms, don't write your own, and then do authentication and authorization checking, right? Those are very basic things. Everybody should be doing them for their application. And, as I look through the schedule and, attended a few talks yesterday, most of the talks I attended were talking about application security. So I don't feel like I have to harp on this any more than just that, right? You guys know how to secure your applications. You're attending this talk because you want to learn how do we go beyond that. So in the case of our architecture, we're going to start with a secure web application. We're going to assume that we've done our diligence to develop something secure, and now it's how do we build our defenses from the inside out? How do we build on top of that as we go? So the cool thing is we've got a clean slate, and I totally realize that a lot of you guys aren't in that position. You come in and there's legacy code and, some dummy, did whatever with the infrastructure, didn't do segmentation or whatever. The cool thing is in Amazon, it's really easy to stand up a new environment, create a new VPC, and, rebuild it in that environment. So, okay. So from there, the question arises, how do we keep our application updated, right? We're going to be releasing new code. Some of you guys are doing agile. There's companies here that are probably releasing code multiple times a day. And so in this case, a few suggestions for you. One, keep the application in GitHub or any sort of private source code repository. And if you do that, you can provide access control over who can push out changes, right? You can say only these users are able to sync into this GitHub repo. The other cool thing is you have auditability. So everybody who makes changes, you have change control. You can see this person checked in this code. Here's the comment that they add. You can see exactly, who did it, and then you can see what was made as well. You can do the diff, and you can see they add this line of code. Why are they, changing the encryption mechanism? Or, oh, that guy introduced a backdoor, right? So as long as you can see what's going on, it's good. And then the other thing is you can roll back, right? If there's a problem in GitHub, you right click and say revert this change, and now all of a sudden you're back to the previous iteration. It makes this really, really easy. And then on top of this, if you can build automation with something like Chef or Puppet, any of these tools for automation, it makes it really, really simple. So when you connect it up, your servers can check and they can say, hey, once an hour, I'm going to check and see if new code is available. And then once I see that that new code is available, I just take it, I sync it down, and we're up and running with the latest code, right? It's automatically rolled out to the servers. And by doing this, we minimize the number of deployment mistakes we have. Every iteration, every server is exactly the same because it's taking it from the same GitHub repo, it's pulling it onto the same servers. It does the distribution for me. Way easier than in the old days when somebody would manually sync down code, copy it over to the server. You'd have to adjust config files and whatever. Now we just put that all in Chef, and Chef does all the magic for us. So we're ensuring that the server configuration is consistent across all these environments. And then the other thing is you can configure different environments based on, this is our dev stuff. So here's that information, and this is our test, and it has this, and then here's production. So we treat it this way. So we can change and we can treat each environment differently, treat our code differently, roll different things to the different environments, based on that stuff. You all with me? Yeah, good. All right. So our architecture at this point is super duper simple, right? We have our web application server. In this case, it's running Apache and MySQL, or Apache and PHP rather. We've got our secure application, which we've done our OWASP best practices approach, and we've developed a very secure application. We have our GitHub repo, which we're pulling data onto our application server, and then we have this orchestration server, which is running our Chef or Puppet or whatever, and grabbing the contents out of GitHub and making sure everything's being synced down. So super, super simple, and we're going to build from there. So the next step is we've got some servers, right? We've got our orchestration server and we've got our web app server. So we probably have to harden these. And in order to secure these servers, again, best practice approach. I'm not going to dig too far into this because there's lots of documentation on there. CIS has some great documentation, but this is standard stuff, right? We want to ensure that we're patching. I was talking with a group earlier over breakfast, and one of the things that I said is that almost all the issues that we see today are because people aren't doing the basics, right? They're not patching their servers, they're not properly segmenting their networks, all these different things. They're not providing, the defense in depth and the least privilege and these very, very simple security concepts. If they're not doing that, they're going to get breached. So we want to make sure that we're doing these. Turn off the unnecessary services. Use a host-based firewall. This is kind of cool because Amazon offers us multiple options. Within Amazon or AWS, Azure, or whatever, you can create effectively segmentation at the network layer where you can say this server can only talk to this server on this port, but why not have the redundancy? We talk about defense in depth all the time. Why don't we practice that? So if we apply a host-based firewall in addition to the network layer firewall, if either one of those fail, if a network admin accidentally disables something for troubleshooting and then forgets to re-enable it, which has actually happened at NI, if something like that happens, why not have that extra defense? Why not have that extra layer, right? And we always want to do default deny and explicitly enable the rules so that we're taking care of security. Administrative access allowed only from a bastion host. So this is one of those things where it definitely reduces the usability, but it way increases security, right? Part of it's obscurity, right? Part of it is I only have one host that I can connect to. And so if an attacker wants to figure out how to get to these other guys, they have to figure out how to get to that guy first. But part of it is you're creating a bottleneck. There's one server that you can focus on hardening that, and you can make that as secure as possible. You can use SSH keys, you can do multi-factor authentication, whatever. But if you create one Bastion host and you say, this is the only one that's allowed to talk to all those other servers, you're creating that additional layer of defense. And then, of course, this is actually a recent addition here because I learned my lesson the hard way, multiple availability zones. So security is confidentiality, integrity, and availability, right? And one of the cool things that I've learned with Amazon is they have this native concept of availability zones. Basically, stuff can run in different data centers or different areas so that if they do maintenance, take something down, a server's having an issue, if you have everything in the same availability zone, then you run the risk of all that stuff going down when the AZ is down. However, if you put stuff in different availability zones, if there's maintenance going on over here, if a server's having issue, whatever, you guarantee that the other one's up. And then you just have a load balancer that spreads across the multiple availability zones. It talks to both of the AZs, both of the servers in those AZs, and then you mitigate against any sort of downtime as a result of that. Make sense? All right, cool. So our architecture now looks something like this. You can tell it's getting more complicated, right? But not too bad. Basically, all we've done is we've said we have a Bastion host now that is connecting via SSH to all these other servers. That's how we administer those, basically connect to those guys and run the scripts that we need or update config files or whatever. And then we obviously want to use HTTPS for the communication between the systems because HTTPS adds transport layer security, and we want to make sure that we're doing that. So from here, we talk about the database. And again, similar to the host-based firewall and whatnot, we have two layers that are available to us. We have the native database security. So this is things like using long and random passwords for the database user account, right? We don't want just, password is password, right? The other thing, and I think people don't do this often enough, is least privilege. So when you're figuring out what privileges to apply to this account, the question that you should be asking yourself is, what does this application need to do? If all this application needs to do is pull some data from the database and nothing else, if it's never writing to it, then why would you give it write permissions, right? If the application is only writing to the database and never has to actually read data from the database, why would you give it read permissions? So start thinking about this in terms of what needs to happen. And again, you may run into the case where usability and security are kind of button heads here. But more often than not, you don't require a lot of extensive permissions. You probably don't need an account that has full admin privileges and the ability to add users and modify user privileges and alter tables and all this other stuff. Most applications do pretty well with read and write. And then you can use an admin account to modify those other ways. And then you want to restrict the host. So when you create these user accounts, you want to say this user is restricted to only access from this particular host. And so in the AWS cloud, that means the server, the application server that's running your application, is the only one that's able to talk to that database, nobody else. On the AWS side, you can enforce the same thing. So you can create a security group, and that security group can have an inbound rule that says the only thing that can talk to this database is this application server, right? So you're making it so that even if there's another server in your environment, even if a server gets popped in your environment, whatever, they can't connect to the database. They'd have to pop another server and then use that in order to get there. We're creating these layers, creating defense and depth. Don't make your databases publicly accessible, right? That's a recipe for failure. The minute you put your databases on the internet, they're going to be attacked. And if you don't do all those other things, chances are it's probably going to get compromised. Or even if you do those other things, maybe an exploit comes out and it's still going to get compromised. So it's best just not to do it. And then again, with respect to databases, leverage the multi-availability zones. This puts the database basically in multiple places, and then Amazon kind of already provides a load balancer for you built into that, where you basically hit the CNAME or the URL, and then it figures out which database is in the right AZ. And if that one's down, it'll use the other one. So leveraging those for availability is good. Everybody still with me? Cool. All right, so architecture now looks something like this, getting a little bit more complicated, but not too much. We now have our RDS database, and so our web application is communicating with the RDS. It's using MySQL in order to do that. but we still have all the other pieces in play. So once we have this, the next step here is to figure out the attack surface. We want to understand if an attacker is going to go after our architecture, if an attacker is going to try and compromise our environment, how are they going to go about doing that? And I know there's been a couple threat modeling talks. This is kind of threat modeling 101, right? So the attack surface of a software environment is basically looking at the different points where an unauthorized user can try to enter data or extract data from the environment. So how are they going to actually compromise our system? And our goal should be to treat our application like a castle. I think castles are really, really cool, especially medieval castles, because when you look at what all they've put together, they've created this defense in depth. They've created multiple layers. I learned something really, really interesting the other day. I'm going to share it with you guys. Maybe somebody here already knows. What's the purpose of a moat for a castle? Anybody know? Was it sharks and crocodiles? It's interesting because most people do think that, right? It's to prevent somebody, give them a hard time crossing it. What's that? Land-based attack. So the real reason why they dug moats is actually to prevent somebody from digging under. They didn't want people to dig under the walls, and so they have this big thing of water around it so that if somebody were to try and tunnel under, it would collapse and it would fill the tunnel with water. That's the point of the moat. Yeah. So it's crazy once you start thinking about all the reasons behind these things. Why do they build these big walls, and why are the purpose of each of these ports so that they can dump boiling oil on their enemies, right? So we like to think of our applications or our architecture as a castle. How do we put up all these walls? How do we build the moats around our application to keep the bad guys out? So let's figure out where our attack surface is here, right? So what I've done is I've said, all right, pretty much everything that's inside my VPC is secure. At least it should be, because nobody's going to be able to directly attack that, right? Especially if I'm the only one who has the keys into the VPC, that's kind of administrative access. But there's two ways that somebody could get into the VPC, right? Right now, if they use the Amazon console, that means that they could potentially get into the VPC, either change permissions or directly connect to servers using console, whatever. The other way is GitHub. GitHub is outside of my VPC. If somebody's able to compromise the GitHub credentials, they're able to attack that application just by nature of being able to change the code that's going to run on it. So we look at what's inside my controlled environment, what's outside. And so now we know if somebody's going to attack the application, it's going to be one of these two ways. So our next step here with our application is we need to enable access for customers, because right now everything's in this tight environment. There is no cloud going into there, right? No internet, and access for the administrators. And so once we do this, our attack surface broadens a little bit. It looks something like this. So we still have that VPC and everything's kind of tight and cozy in there. I've added a load balancer here for availability so that we can basically from the outside people can connect in so our customers can access the application. But this also opens up the attack surface, because now somebody can connect via HTTP or HTTPS to that load balancer, and they can now access into the application, right? In addition to the console access and the GitHub access. So what we do now, the load balancer in this case acts as a proxy, right? So we can have as many servers as we need behind it, and then the end user only accesses that load balancer. So now that we've done this, we can figure out what our attack vectors are. Basically, we know what the surface is. We know what the openings are. Now, how is somebody going to compromise my environment? So with the attack vectors, what I've done is I've said, all right, what are these? So we have insider access, right? They're able to get in, compromise confidentiality, integrity, availability, whatever. We have somebody compromising Amazon, make changes to the configuration in the environment. We have them compromising GitHub, and they push malicious code into the environment. We have them finding some sort of vulnerability in the application, and they use that to gain access to the environment. Maybe it's a SQL injection or something, remote code execution, whatever. And then maybe it's my Bastion host. Maybe they're able to figure out a way to connect to that. So let's address each of these, right? That once we know how somebody's going to come in, let's figure out how do we prevent that. So we'll start with the insider threat. In the case of the insider threat, there's not a lot that we can do, right? Because they're insiders. They're people that, at least in theory, we trust. what we can do is we can trust but verify. We can do background checks and make sure that the person is who they say they are. I was talking with John Dixon from Dem Group yesterday, and he relayed some interesting information to me. He basically said that he was talking about how important background checks are, and he used this one particular situation that he encountered where they hired a person to handle some money, basically be a comptroller for a particular organization, and that person ended up, they didn't do a background check. That person ended up stealing tens of thousands of dollars from the company, and they tracked this all down to this person had a history of fraud. This person had embezzled from prior companies, had convictions, and had they done a background check, they would have known, right? But they didn't, and that resulted in multiple people resigning, that person obviously getting fired and brought up on charges and all that stuff. So extremely important to vet the people who are going to have access to your environment. And then obviously the second point here is we want to limit who has access to our environment. We want to make sure that the right people that the people entering our environment are people that we trust. So tighten that circle. We don't want a ton of people. In fact, we don't need our developers to have access into this environment, right? They do all the GitHub-y stuff. They check in the code. So they don't really need that access to push code out. We've got Chef that's doing that for us. They don't need to touch the servers. All right. So then we have Amazon. Amazon, so they have, one of the things they do really, really well is the identity and access management. They've got tons of functionality in there for defining who can do what in the environment. So you start off by limiting who has access, right? We don't want just everybody to be able to get into AWS. We want them to be people who we know and trust and whatnot. We want to use our role-based functional authorization. So they, maybe this person has the ability to provision new servers, but they don't have the ability to provision new users, right? That would probably be very different sets of functionality, and we won't want them to have both. Ensure password requirements are being met so that they're actually using long random passwords, and then require multi-factor authentication. I think it was one of the talks yesterday where they were saying require a minimum of 12 characters if you use multi-factor, or I think they said 20 characters if you're not, right? So multi-factor is becoming more and more important, and we want to make sure that we're doing that. Okay, so then we have GitHub. For GitHub, again, limit who has access, right? We want to make sure that the right people are able to access to this. And in this case, we may not want system administrators to have access into GitHub. Maybe that's a dev role, right? And so only the developers are checking stuff in. Or, our VP of sales definitely doesn't need the ability to check code into GitHub. So we want to make sure that we're limiting who has access. We want to ensure long and random passwords again, and then we want to require multi-factor authentication. And it's right about this point where people start asking, well, you said long and random passwords here and here and here. I'll just create one long and random password, and that's the one that I'll use. It's like, oh my God, no. Use something like KeePass. Use a password manager. Create long random passwords for each unique use case, and then track them in your password manager and use one code to unlock all of them, right? That's how we're going to have secure long and random passwords, and not just, hey, if my one password gets breached, then every single one of my accounts gets breached. Right? And then multi-factor ensures that even if one of those passwords gets stolen, there's something but then there's also something you have in order to do that. And then the last little bit here is auditing. We want to make sure that somebody is actively looking at what's going on in our environment, not just that stuff is going on in our environment. So audit the changes. Make sure that what's happening in the environment is what you expect. That conversation with John yesterday, he also said, the place where fraud gets revealed in a company is when somebody takes vacation. And if you find somebody in your company is never taking vacation, there might be something wrong there. Tell them take 3 days on your own, go take care of the kids, go on mini vacation, whatever, because that's where fraud gets exposed. Kind of interesting. John's a smart guy, by the way. You should definitely sit down with him. So now we've gone through, we've talked about Amazon and GitHub and whatnot. The next piece is our application, right? And so for our application, the OWASP top 10, and I think I put this together before 2017 came out. 2017, a lot of the stuff is the same, but they've also introduced some new stuff as well. So look at the OWASP top 10. That doesn't mean that the OWASP top 10 2013 isn't relevant. It's just not the biggest risk, right? We've moved on a little bit. People are fixing some of these issues, as Andrew explained yesterday. But we still want to make sure we're doing HTTPS. Redirect HTTP to HTTPS. We're using HTTPS by default. Part of what goes along with HTTPS is making sure that you're using proper HTTPS. If you haven't used it before, SSL Labs is awesome for this. You basically go, you enter the website that you're running, and it'll go and it'll check it. And it'll tell you, hey, you get an A, you get an F, right? And it's just like back when you were in elementary school. If you get an F, you should, put on the sad frowny face and go and study harder and do better, right? So things like making sure that you have a real SSL certificate, not self-signed certs. In this day and age, there's no reason why anybody here should be having a self-signed cert. You can go and you can use Let's Encrypt, and you can create an SSL certificate and automate it so that every 30 days it changes and creates a new SSL certificate for you, and it costs you $0, right? Maybe a little bit of your time to create the automation around that, but that's the idea, right? Once you automate, you one and done. It's going to rotate automatically for you. Along with this, make sure that you're using strong ciphers, something like a TLS 1.2, and that you honor the order of those ciphers, because otherwise what happens is you can negotiate between the client and server, and you can say, give me the least amount of security, and the server says, okay, and now all of a sudden all of these other attacks open up because you've downgraded the SSL. Going along with this, some classic things like using a web application firewall, using an IPS system. If anything, these give you visibility into potential attacks. You can see when somebody is poking and prodding the application, and you can see that thing, even if it doesn't necessarily stop it. And then obviously the last bit is application security. Do the stuff I talked about up front. Do the OWASP top 10. Understand the OWASP-ness of the application. We're gonna like trademark that phrase. I like that, OWASP-ness. Okay, so remote access. That's the last little bit here. Somebody has to be able to get into the environment to administer it. If something breaks, if something's not working properly, if you need to add new functionality or whatever, somebody ultimately is going to need to have keys to get in here. So for this, use the long and random passwords for the SSH user. Use multi-factor authentication. You can use your key, use your phone, TOTP protocol, whatever. You can also use key-based authentication, and you can do a combination of all three. So you can require an SSH key and a password and the multi-factor authentication and make this the most secure, least usable application of all time, right? Restrict what IP ranges are allowed to talk here. This is a big one, because what happens is if everybody has access to SSH into this application, then everybody's going to try to SSH into your application. If you've ever audited the logs of a publicly accessible SSH server, man, root tries to log into that thing all the time, right? And they try lots of different passwords. Going along with that, don't allow users to log in as root. Like that every attacker is trying to guess the root account, and if the root account's not allowed to log in, like you're in a much better place. Disable SSH unless if you're VPN'd into the VPC. So if you can take that Bastion host, you put inside your VPC, and then you say you have to be able to get into my environment via VPN in order to access even the Bastion host, which you then have to have access to the Bastion host in order to access the other systems. Again, you've created a very secure but less usable environment because it requires these multiple hops. All right. So with that, we are getting close to done. I wanted to make sure I left some time for questions, but I wanted to leave you guys with some recommendations. One critique I have of a lot of talks is they talk a lot about problems, they don't talk a lot about the solutions, and so I want to make sure that I left you guys with something that you could take away here. So step one, when you're looking at an application, determine what is or is not in scope. There's going to be things that are outside of your control. You may be dealing with outside vendors, you may be dealing with outside services, some other team owns that thing. If it's something that you can't touch, then it's really hard to threat model it. But what you can do is ask questions. So get something like the shared assessments document, the SIG, whatever, and ask those questions. Do a risk assessment of those environments and make sure that you understand the risks involved of dealing with that particular vendor. Okay? Second piece is create a data flow diagram. Understand how the data flows from one piece of the application to another. One of the other things we talked about at the table this morning over breakfast was the idea of threat modeling and the data flow diagrams. It's not only useful in the application space, it totally is, but it's also useful from a troubleshooting perspective. You know, back when I was a web systems engineer, if an application broke in the middle of the night and I didn't have documentation on how that application worked, on how the data flowed through the application, it made it really hard to troubleshoot because it's an application somebody else wrote. You know, we may have deployed it, but a deploy isn't the same thing, you know, once you're trying to go through troubleshooting mode. So if you have an application, if you have a data flow model for that application, you can understand, hey, this application depends on these services, these databases, whatever, and you can use that to figure out, you know, what broke, what's the problem there. Identify the attack surface, look at where the openings are, where somebody might be able to hit this, and then once you do that, identify the threat vectors. So what is going to attack it? Where are they going to come in at that application? And then the last little bit is do your basic risk management, right? Understand what the risks are, and then plan the mitigations to reduce the risk of those threats. Make sense? All right. Questions? Yeah.
Do you have any suggestions for how to choose a CASB vendor?
Choose a CASB vendor. I looked briefly into the CASB is Cloud Access Security Broker. I looked briefly into them, and I didn't really find one that I really liked. So no, I don't have any good suggestions there. I'm sorry. I'm useless on the CASB side. Other questions? Know when to say I don't know. Yeah.
There you go.
So for larger enterprises that they have a lot of assets in cloud like AWS or Azure, what do you suggest for tracking the assets and the inventory and things that has been abandoned in there for a long time and can be used in different ways, in malicious ways?
Yeah, so one thing that I didn't really talk about here, and maybe that's a good suggestion for improvement, is vulnerability assessment and scanning, asset scanning, inventory, that kind of thing. Having a tool like a Nexpose, a Nessus, a Qualys, whatever, is definitely a positive thing because it gives you the ability to not only figure out what's responding in your environment, but figure out what ports are open on those devices, and then figure out what applications are running on those devices. And that's part of the threat model, is understanding what those openings are, right? And so I guess my recommendation to you would be to make sure that you have a tool like that's on a recurring basis, daily, weekly, monthly if you have to, is scanning the environment, finding new assets that get stood up, and then assessing the risk involved with those assets. And so that's understanding what ports are open, what protocols they're running, are there vulnerabilities with that particular version of Apache that, you know, that thing is running, those kind of things. I think that'll get you most of the way there. It's a really good suggestion for improving the deck too, by the way. Other questions? No? All right. Oh, we got one.
So when you access the cloud, you begin and use the cloud, what platform do you run? Are you running Red Hat, whatever AWS provides?
You talking
provide
servers or my personal system?
Well, your stuff's running an application on Apache, and Apache runs on ? And then how do you secure that?
Yeah. So in my case, all of our servers are running on Ubuntu. What I've found is Ubuntu is really easy to get set up. Security is pretty basic on there. The base configuration is actually pretty secure. They don't allow a lot of services running, especially publicly accessible stuff. UFW is the Universal Firewall, runs on Ubuntu, and it's very easy. UFW enable, and all of a sudden you've got firewall for the host-based firewalling stuff. And it's a very straightforward OS. So, and it's native to Amazon. So that's what we found works really well for us. But if you run a Windows environment, you can certainly run SimpliRisk in a Windows environment, and it's just a matter of following the best practices, following what the recommendations are for hardening that particular OS. And that's why I mentioned CIS earlier. The Center for Internet Security has a list of here's how you develop a secure host baseline for Linux, for Windows, for whatever. So that would be my recommendation. Is it really doesn't matter what your OS is. It's kind of like when I started talking out. It doesn't matter what you're running this on. In my case, it's PHP. Somebody else could write it in Java or whatever. Same thing for the OS, right? Everybody has a different preference. It's going to depend on who your admins are and what their skill set is and whatever. You don't want to force them into using Ubuntu because Josh says use Ubuntu, right? If you have Windows administrators, they're good at administering Windows, right? If you tell them to turn off a service, they know I go into start configuration services and I disable services, right? So don't force them into something else, force them out of their comfort zone. Try and figure out how to work within that comfort zone. Yeah. So for the purpose of video, what the gentleman was saying was that Amazon actually does have CIS hardened images that are stock in there. And so you can select those and they'll give you that baseline of security. The challenge is once you try and scale those out, then you run into some issues with configurations and whatnot that you have to work through. So, cool. All right. Thank you guys. Appreciate it.